The same basic idea works in this row too. The difference is these molecules are a little more complex, but there's one less of them. Yes, sir.
Okay. On highlights with Sp2, are them red lines going through them? Are them other balloons combined together, or?
I'll get to how the balloons put together just then. I'm going to go through all that over here. I got instructions for that. I'm going to go through it with you, okay? All right. So here's our original. When you do Sp2 hybridization, at least one p orbital does not hybridize. You have to have an unhybridized p orbital for the pi bond to occur. So this illustration shows we can overlap the hybridized orbital, but this p orbital here doesn't hybridize. It allows it to do that pi bond across the top and bottom that we explained yesterday. You guys all got up here and tried to show how it happens. Today we're going to see how it does happen. So this overlapping orbital here, this hybridized orbital, makes a sigma bond in between the two nuclei. These two p orbitals that don't hybridize form a set of nodes that make a single pi bond across the top and bottom. Okay? Making a double bond. Sigma, the pi bond, two bonds. Okay? This is called an ethene molecule, the double bond. One sigma, a sigma going to a hydrogen right here, another sigma going to another hydrogen, the same on this side. One sigma between the two carbons, one pi between the two carbons. Okay? You can also make this molecule here. Okay? In this case, nitrogen already comes to that molecule with a lone pair of electrons that it's not going to bond anything with. So we have to have a lone pair over here on both nitrogens. We still do a sigma bond in the middle, do a pi bond on both sides, and we have one pi bond to a hydrogen, giving nitrogen all of the electrons it needs for a full valence level. Okay? All right. Starting out with the same thing here with an unhybridized p orbital, we can form an oxygen molecule. Okay? Oxygen came to the molecule with 6 valence electrons. It only needs 2 more, so it can only form 2 bonds. So when it forms a sigma bond and a pi bond, it's done with its bonding. Everything else that remains then are these lone pairs, so it's going to have 2 sets of lone pairs on each oxygen. Any questions about that?